Okay, so today we're going to look at finding the sum of a finite geometric sequence. We talked about how to write a geometric sequence in the previous video, and that's what you're seeing right here. Today we're going to actually find the sum of that finite geometric sequence. Now there's one slight correction that we need to make here. This should be I minus 1. It'll connect a little bit better when we start actually doing our examples. Okay, so what this says is to find the sum of any finite geometric sequence. We're going to start at some value 1 or I, okay, go up to some value n. Those will be the terms that we're adding together. We use the formula that we saw in the previous video, our first term times r raised to the I minus 1 power. And the formula, or the sequence, actually adds up to be this. Take the first term and multiply it by this quotient. And we're going to look at what that all means here in the next example. I don't want you to get thrown off by the fact that you see an I instead of an N in this formula. It's just a different variable. It's no big deal. We can use any variable we want there. But what's important is that we can use this formula. So let's actually connect this to what we're seeing. We've got I equals 1. We've got N is 12. I'm going to start writing some of this down. We know that N is 12. Okay, so we're finding the sum of the first 12 terms of this sequence. I can connect A1 in my formula with A1 in the problem. So now I know what A1 is, 4. And I can find my common ratio, which is R. Whoops, sorry, didn't use the highlighter there. Which is R with R in the actual problem I'm given. So now I know that R is 0.3. So I have everything that I need. If you look at the actual formula that we're going to be using, A sub 1 we know is 4. R we know is 0.3. So this is 0.3. And N is 12. We have everything we need to find the sum. So let's actually work through it. Okay, so the sum of the first 12 terms of this sequence will be A sub 1, and I'm using this formula right here. A sub 1, which is 4, times 1 minus my R value, which is 0.3, raised to the nth power, over 1 minus just my R value. And then at that point, guys, it's strictly a calculator problem. So get your calculators out, see if you can figure that out. All right, so if you do that on your calculator, you're going to get 5.7143 as an approximation. We have to approximate here. It's not going to be an exact value. Okay, so let's go ahead and jump into actual geometric series here. So when we're finding the terms of an infinite geometric sequence, that's the difference here, is we're now talking infinite. We call it an infinite geometric series or just a geometric series. We don't have to use the word infinite in front of it. It's kind of assumed. So we can use the formula for a finite geometric series to help develop this formula. If we think of the absolute value of R being less than 1. Now, what that means is that you're talking about fractional values. So like 1/2, 2/3, 3/4. Those are all values that are less than 1. But we could also have stuff like -1/2, -2/3, -3/4. Those are also values that will have an absolute value of something less than 1. We're really talking about looking at R values between, let me write this the right way here, R values between -1 and 1. Not equal to, just between -1 and 1. That's really the same thing as what we're saying in that little expression above. But when we think about R sub or R to the nth power, as our n values get really, really, really large, that R value will approach something. And think about what that might be. And if you're having trouble with that, take a number like 1/2 and raise it to the 3rd power. Then take 1/2, raise it to the 5th power. Then take 1/2 and raise it to the 100th power. 1/2 raised to the 1000th power. And tell me what you're starting to see about that number. It should be getting closer and closer and closer to 0. Okay, the bigger that power is, the smaller the number will be. All right, so what that does is if we think about R sub or r to the nth power getting closer or approaching 0, the larger the n value gets. When we're talking about r to the infinity power, it is for all intents and purposes 0. So we have that here because our infinite sequence is talking about n approaching infinity. So all of that leads us to this formula. And again, this is for an infinite geometric series. The previous formula was for a finite geometric series. So once again, we don't need the infinity written here because without it, we assume that we're talking about an infinite series. All right, so the sum is from 0 to infinity. Okay, so an infinite sequence. A sub 1, which is our first term, times r to the I power, whatever that is in our sequence. And notice this starts at 0, not at 1. That's a slight little difference. It's not a big deal. We'll adjust for that. This is still going to tell us our a sub 1 expression. And then we have a sub 1 divided by 1 minus r, because this ends up just being 1. And when we multiply that all together, we get this expression. Nice thing about finding the sum of an infinite geometric series is that there's less information that you need to know. And I've sort of highlighted in our formula the important pieces of information. So for us, in this first example, we need to know what a sub 1 is, and that's right here. And then we can also find our r value right there. So I'm going to write those two things down. A sub 1 is 4, and r is 0.6. Well, now we've got all we need to find the sum. So the sum of this geometric series is going to be a sub 1 divided by 1 minus r, which we know a sub 1 is 4 divided by 1 minus r, which we find is 0.6. Okay, so then that's just a matter again of using our calculator. And when you type that in your calculator, you get 10. Now that's interesting because what's happening here is we're saying that if you were to list for an infinite number of terms this sequence that we were given, so an infinite number of numbers ends up being a finite sum. And we saw that in some of the previous videos where that happened. So this is, not something that I think you're going to be completely surprised by, but for some of you it might be kind of a little shocking. Okay, go ahead and try part B. See if you can figure out what r is, and then find your sum and come back and we'll check your answer. All right, so just to kind of give you an idea of what I did here, I started out by figuring out what r was going to be by taking any term and dividing by the term in front of it to get my r value of 0.1. I knew that my first term was 3, and that's everything I need to find my sum. Plug those two numbers in and use the calculator and you get 10/3. Okay, as far as the applications of geometric series goes, I'll do the example and it's kind of like the application in the previous videos. If you want to try it, give it a shot. If you don't want to try it, you don't have to. You can stop the video here and be done. If you do try it, come back and check your answer. If you're trying this problem, as you read through it, here's some of the answers to those first 4 questions. The next few things can be a little confusing. If you're trying this, just understand that that first payment of $50 will have 24 different calculations of interest. So really the first payment we look at as term 24 because it'll have 24 months of interest. The second payment will only have 23 months of interest. So that's why we're calling the second payment A sub 23. The last payment will only get 1 month of interest, which is why we're calling it A sub 1. So that number, that n value, is really talking about how many months of interest you get for that particular payment. All right, so think of it that way when you're trying to figure out these numbers. And then you've got your 3 terms that we're asked to find. So if you're doing good so far, go ahead and try this last part of this problem, which is actually finding the total balance of the annuity. And we've got it kind of written out here. You're going to have to use that formula that we talked about for finite sequences here, for a finite geometric sequence. So the first formula we talked about, So go back, use that, see if you can get the total interest, and come back and check. Okay, so I used the first formula, put in the numbers that I know, and used my calculator to do all the hard work. Remember that this problem was optional. You won't see anything like this on your check-ins. Okay, have a great day. We'll see you in the classroom.